Good day, everyone. Welcome to Direct Stars. Our subject for today is physics, where our topic is factor affecting gas pressure. Okay, aim of today's lesson is for you to understand the factor affecting the gas pressure. Objective for today's lesson is for you to know how this pressure of a gas in a sealed container is affected by changing the temperature of the gas and the factors affecting gas pressure. So we go to gas pressure. Gas pressure. In the first place, you need to understand that we don't eat food in a sealed can. Do you know why? Because the can will probably explode because of the pressure of gas inside it increase and temperature increases. Okay, so this is because the molecules of gas in a can collide repeatedly with each other. So you see, with this molecule collide repeatedly with each other, the force is exerted on a certain area in the can, and that is what we call pressure. Okay, so each impact with the surface exerts a tiny force on the surface. Millions of these impacts happens every second. And together, the total forces causes a steady pressure on the surface inside the container, while this pressure on the surface is totally exerted over a unit surface area. That is why we have pressure equals to force over a certain area. So now, my question is, what really happens that we have this pressure? We have this pressure just because there's increase in temperature. You know, when there's increase in temperature, the molecules in the gas will try to move repeatedly, colliding with each other. Like the velocity in which they move is so fast. So we have gas pressure is influenced by several key factors, all rooted from the kinetic theory of gas. Here is the breakdown of it. We have temperature. You know, increase in temperature in gas also increase the kinetic energy. Remember what kinetic energy is? Kinetic energy is the energy that an object possesses due to its own motion. So when there is increase in temperature, there will also be increase in the molecules of this gas due to their own motion. Okay, so they move faster and collide more frequently and forcefully with the container walls. So these container walls, when we have this particle try to collide with the walls, so at this certain area, there is a force there. So that's where we have our force, while the area here, that's where we have over area. Understand? That's why we have pressure equals to force over area. So this result gives high temperature, and this high temperature gives high pressure. With this high pressure, but volume is constant. What's volume? This is what we call volume. The volume is constant. When there's increase in temperature, there will be increase in this pressure. What do we call this pressure? The pressure is when the force of these molecules are attained to a certain area of the container. That is when pressures occur. So, and again, we still have what we call volume of container. What are these volume of container? We are talking about the effect of this gas pressure. What really affect the gas pressure? Okay, volume of container. You know, sometimes there might be little volume, and we can have large one there. So reducing the volume means particles have less space to move. You know, when particles in this volume, they have less space to move. So with that, they collide with each other repeatedly, one another repeatedly. So they hit the walls more often, and when they hit the walls more often, there is pressure. So this result causes small volume, gives high pressure, and this high pressure is caused by the temperature and the amount of gas are constant. That's what obeys from Boyle's law. Remember what Boyle's law is? When volume is directly proportional to the pressure itself. So amount of gas, we have number of particles. Number of particles in the container also affect gas pressure. So these are particles in the container. So when more gas particles gives more collision with the container walls. While this results, when we have more particles, there is more high pressure and the volume of the temperature are constant there. And we also have the nature of the gas. Yes, the nature of the particles here, you know, we have different gas. So the nature of the gas also causes the pressure on that gas. Okay, so heavier or more complex molecules may behave differently under the same condition, while some gases are more compressible or reactive than others, which can influence the pressure in real-world scenarios. You know, we have different gas. Okay, so nature of the gas also, it increases the pressure on the gas itself. Okay, so these all affect gas pressure. You have temperature, volume of the container, amount of gas, and nature of the gas. Okay, so that will be the end of today's class on factors affecting gas pressure. See you in our next class. Please don't forget to click on the subscribe button and share. Bye.